Hello, and welcome to part 2 of the FoRRwD series, focus on reducing rural roadway departures. My name is Paula Hyman from the Ohio LTAP Center, and I will be your technical support for today's webinar. Before we begin, just a couple of items. If you have questions throughout the presentation, please type those into the questions box, and our presenter will address your questions periodically throughout the presentation. If you look in the handout section, there are documents available to download. If for some reason you're unable to download those handouts, they will be emailed at the completion of the webinar to the group. This webinar is being recorded, and providing that the recording is successful, a YouTube link will be emailed out to all participants and uploaded to our LTAP website. Thank you in advance for your participation. And with that, I'll pass things off to Mr. Ray Brushart, Safety Circuit Writer with the Ohio LTAP office. Ray?
Thank you, Paula. Good morning, everybody, and welcome to part 2 of 4 of our webinar series on the FoRRwD initiative. FoRRwD stands for Focus on Reducing Rural Roadway Departures. And today we're going to take off where we left off last week with our talking about signs and how the roadway signs can help us reduce our roadway departure crashes. We kind of ended on talking about curve sign enhancements, but a little bit to talk about a little bit about last week to summarize. We talked about what is a roadway departure crash, and that's a crash in which a vehicle crosses an edge line, a center line, or otherwise leaves the traveled way. So they were in a crash where they left their lane of travel, either to the left or right, basically. And we need to focus on these types of crashes and see what we can do to lower the number of these types of crashes, especially in our rural areas. So we're really focusing on our 2-lane rural roadways here. So some of the things we talked about with our signing is and how it is involved with the OMUTCD, the Ohio Manual of Uniform Traffic Control Devices. As we look at part 2 of the manual, that's where all the information is on our roadway signs. They have our minimum standards, and then we can go above and beyond those minimum standards with options and other enhancements, like in the picture here on the top right. We don't just have one advanced warning sign for that really sharp curve there. We've doubled up the signs, and then we've doubled up the posts, and we've put the strip, the reflectorized posts on them, and we also have the advisory speed plaque attached to the signs. So and then we also went over, when is the advisory speed plaque required or recommended. So we went over that table 2C-5, and we also looked like in the bottom picture there with the reflectors there, the delineators, but how to space them properly. We actually showed you a table that shows us how to properly space them as well. The chevrons. Don't you hate it when you forget a word? I usually forget the word chevron. What, does anybody else have a word that they just can't remember? They always have to look it up. Chevron is that word for me. So there you have it. So there are, these are examples of how to go above and beyond the minimum treatment for a curve. Okay. And so, these are low cost treatments, about as low cost as you can get to reduce crashes. So, if you have a sharp curve and you've got a 55-mile-per-hour 2-lane rural road, you shouldn't have the minimum sign up there. We want you to enhance that. Another thing we talked about in the first session was that how fatal crash locations are random. You could fix the problem in one curve, but there won't be another fatal crash there for 5 or 6, 7 years maybe, or something. Hopefully never, but a curve similar to that will have one. So, you know, so the slide said fatal crash locations are random. However, the fatal crash types are predictable. And so that is the basis of our systemic safety improvements. You know, we want these improvements to be widespread and they're low cost. So, you know, the first in the bunch is our signage. And so this is why we spent some time on specifically curve signage, because we learned that, you know, most of the bad crashes on two-lane rural roads happen in the curves. So we need to, as part of the low-hanging fruit, let's do what we can to lower the number of crashes in our curves. So the number one easy, low-cost way is the entire curve signage package, from the advanced curve warning signs and the different enhancements with that particular sign, as you can see. And then as you approach the curve with our chevrons and the large arrows and things like that. So, and then as we take a closer look at chevrons, we can go above and beyond on those as well. They have these sequential flashing chevrons. As you can see in the picture, you'll see these used out west, because those curves out west in the mountainous regions are quite spectacular, and you definitely want to make the curve. You don't want to miss that curve, or you'll be off the side of a mountain, right? So, you know, they developed these sequential flashing chevrons, and they've studied these. As you can see, some study results in the table on the left. They have the average change across all sites at the point of curvature, and you know, they have differences in amount of time that these sequential chevrons have been in place, from 1 month to 2 years. And it says change in fraction of vehicles exceeding advisory speed by different speeds, 5, 10, 15, and 20. And as you can see, they have some big changes, dropping them by 30%, sometimes close to 40% or 48%. So they do make a big difference in driver behavior, getting them to slow down. Another thing is with this class is we have handouts for you, and they're in the we have a handout box that you can get to and download the PDFs for all these slides. And one of the good reasons why you want to download them is because, as you can see in the upper right corner of this slide, is a little reference manual, a final report on this specific type of curve warning system. But there's all kinds of, we've included a lot of different reference materials throughout all these slides. So there's a lot of material for you to check out on all of these different methods we have to lower the number of crashes. Countermeasures. So here's a slide to our video to check out about these curve sign enhancements, the sequential flashing chevrons.
Today we'll take a look at TAPCO's Dynamic Curve Warning Systems, or DCWS. These DCWS feature TAPCO's flashing LED blinker signs, which are solar-powered traffic signs enhanced with brilliant LEDs. The blinker signs provide advanced warning of and guidance through the curve and are ITS compatible. Statistical analyses show that approximately 3 of every 4 curve-related fatal crashes in the U.S. involve single vehicles leaving the roadway and either striking fixed objects or overturning. Another 1 in 10 result in head-on crashes. Also, the average accident rate for horizontal curves is about 3 times the average accident rate for straight segments. Thus, fatal crashes on rural curves represent an important crash category, and improving the visibility of rural curves at night has been shown to reduce this type of crash. An advanced warning system lets a driver know that the horizontal alignment of the roadway is about to change and that the driver must alter the path and possibly his or her speed to negotiate the curve safely.
Okay, I wasn't sure if everybody could hear that. Maybe you could, maybe you couldn't, but at least you could see the sequential flashing chevrons in action there, and a pretty spectacular curve there out west in the Rocky Mountains. So another curve sign enhancement we have are these driver feedback signs, and there's an evaluation of these dynamic speed feedback signs there attached. You can download and review as well, and it shows the results of their studies on how they can reduce the crashes. And they have different designs for these feedback signs, as you can see. So those, if you have a real problem with a really sharp curve, then you can try out this method, this countermeasure. Another thing that you've noticed in the last 10 years is that our roadway signs have been improved as far as their retroreflectivity. And so retroreflectivity is critical for nighttime visibility. And as you could check out the picture there on the right, you can probably figure out which signs are the most visible at night. So our traffic control devices should show the same color day or night. And retroreflectivity is the property of the device to reflect light from the headlamps back to the driver at night, usually using beads or prisms to reflect the light and color. So there are some minimum retroreflectivity requirements that agencies are required to have a method in place to evaluate their signs' retroreflectivities. One is a visual nighttime inspection method. And there are 3 approved procedures for signs. These are all nighttime inspection procedures. Then there's the measurement method. This could be done any time of day. They have a retroreflectometer that you can use to do that. We're actually getting some retroreflectometers here at the Ohio LTAP Center, and we'll be able to loan those out to different agencies, so you can request to borrow those very soon. And then they have 3 management methods for the retroreflectivity. They're based on service life or control signs or a blanket replacement. So additional information, including a methods document is available on the MUTCD website. And we also have some information on the Ohio LTAP website about coming up with your own methods of sign retroreflectivity assessment. So it looks like the second stop sign at the top left looks like that was the best. Okay, so sign conspicuity. It's important for people to see the sign, right? And so the signs, for them to be seen both day and night, they need to be aimed towards the approaching traffic. So in the top picture here, it looks like, you can see all 3 of those chevrons during the day, but at nighttime, that third one disappears because it's not aimed properly. So you need to make sure that the chevrons are aimed properly. And this may require devices to mount the signs for both directions. So this picture at the bottom here, it shows like a butterfly attachment for so that the chevrons can be visible in both directions using just one post. In addition, vegetation and other obstructions to the signs should be removed. So this is definitely the time of year for agencies to be out there taking part in their vegetation management program. I know every April here at Ohio LTAP, we have a vegetation management conference. and it allows the workers from local agencies to get their certifications and different chemical spraying and things like that to help with their vegetation management. But yeah, we definitely don't want to have vegetation growing over the signs. And so this is the time of year that we need to be out there taking care of that. So that was what we have to talk about there about signs. And then our next countermeasure that we want to discuss is pavement markings. So this is a lot of this information you'll find in part 3 of the OMUTCD. And then we'll also talk about not just what's in there, but some other things that go above and beyond what's in part 3 of the manual. So the different crash types that are addressed by pavement markings are curve crashes, head-on collisions, nighttime crashes, and the different pavement markings might include edgeline and centerline markings, delineators, or raised pavement markers. So let's first talk about our centerlines and edge lines. The MUTCD talks about different requirements and recommendations for centerline markings. It states that the centerlines should be placed on all rural arterials and collectors with a traveled way greater than or equal to 18 feet wide and an ADT of greater than or equal to 3,000 vehicles per day. So that's the should condition. And then the edge line markings, the MUTCD says that these shall be placed on rural arterials with a traveled way greater than or equal to 20 feet wide and an ADT greater than or equal to 6,000 vehicles per day. And the markings should be placed on rural arterials with a traveled way greater than or equal to 20 feet wide and an ADT greater than or equal to 3,000 vehicles per day. So there's a difference between standards and guidance. That's the shall and the should conditions. So as you can see in the picture, it really does make a difference to the motorists as they approach a curve and drive through a curve. You know, they can picture and get and estimate how they need to drive through that curve from a distance, and then when they get to the curve, the pavement markings provide them the guidance from beginning of curvature to end of curvature, all the way through the curve. And so the Highway Safety Manual includes a lot of information on edge and centerline markings as well. And you know, they have a chart here that shows the potential crash effects of placing edge line and centerline markings on your roadways. And so if you have the combination of edge line and centerline markings on a rural 2-lane road, or even multi-lane undivided with an unspecified traffic volume, so it could be any traffic volume from low to high, and the effect on a severe crash types with injuries has a crash modification factor of 0.76 with a standard error of 0.1. So just having the paint on the roadway gives you a 24% reduction in your crashes. So like I said, we're talking about low cost treatments. So pavement markings definitely foot the bill for that. So I've noticed even the road that I grew up on all my life down in Pike County, it never ever saw pavement markings until this past year. And so maybe it was the gas tax or whatever, but the Pike County engineer finally decided to put pavement markings on that road. So I can't wait to see any crash data from before and after with that, because it's definitely a curvy road. So out in Missouri, they did an edge line case study, and a little background on it. Prior to 2008, Missouri DOT did not stripe edge lines on roads with less than 1,000 vehicles per day. And they had approximately 18,000 centerline miles of road that had an ADT of less than 1,000 vehicles per day. And of these, approximately 7,500 centerline miles, 1/3 of the mileage of the road, had an ADT between 400 to 1,000. And these roads had 219 fatalities and over 1,500 severe injuries in a 3-year period, and represented 2/3 of all of the overall crashes in that state. So Missouri DOT decided to provide edge lines for the roads with greater than 400 vehicles per day to see if they could put a dent in a number of these crashes. And so they went through the entire study process here with it was a real study with the Bayes method and all that stuff. And so they had to observe crashes in the before period from various counties, and observe crashes after the period, and they had a percent change for effectiveness. And so as you can see, they just by putting edge lines on this road, just by putting paint on the road, they had anywhere from 15 to almost 20% decrease in the number of these crashes. And so that was at the 95% confidence level and 90% because they used the Bayes methodology in this research study. So edge lines do make a difference. You get a lot of bang for your buck with edge lines. So another thing they did with edge lines is they enhanced them by making them wider than normal. So the normal edge line is 4 inches wide. And what they did was say, well, what if we made it wider by 2 inches? So they made it 6 inches wide. So by making it 6 inches wide, they studied this countermeasure. And as you can see, for all crash types and the crash severities ranging from fatal, serious injury, and minor injury, and they studied it on principal arterials, other freeways, and expressways in rural areas. And just by making it 2 inches wider, they reduced crashes by 22%. So that's a good reason to make your pavement, your edge lines wider, especially in the curvy areas. Another pavement marking enhancement we have is raised pavement markers. It seems like we don't see much of these anymore because of everyone says that the snow plows rip them out of the pavement. But let's see what we have here. It says raised pavement markers may supplement or substitute for edge lines and or center lines, reflective or non-reflective. And so they developed a recessed pavement marker, which to address the snow plow problem. So you can recess them. And it says they had a maintenance thing on there. Let's see what it said about the maintenance. Let's see here. So says some agencies use non-reflective for lane lines. The button variations shown in the right photo. Let's go back. The button type down here at the bottom are likely non-reflective due to the shape. They're circular. The raised pavement markers are historically difficult to maintain. A key is the adhesive or binder used. Types are hot bitumen and epoxy. There are maintenance issues, especially where snow plowing is required. It says in lieu of replace, MUTCD uses substituting. So some maintenance considerations are minimum retroreflectivity levels, resources, budget, pavement type, snow operation, maintenance. It says RPM shoes are glued or fastened into the road bed. Shoes can dislodge and damage vehicles. Most agencies no longer use the shoe. So we've learned a lot of lessons with raised pavement markers, but we do know their benefit for helping to guide motorists along the roadway. And so, one of the things that they've looked at is the recessed pavement markers to address the problem with the snowplows knocking them out of the road and knocking them loose, and how they could fly up and damage cars. So hopefully the recessed pavement markers will be more successful, so we can use them more often. Okay, our next countermeasure is delineators. And so delineators provide guidance at night and during adverse weather, and they remain visible when the roadway is wet or snow covered. So here we have some post-mounted delineators, and then you can see another product type here on the right. It looks like a circular post with a bigger target, more retroreflectivity. The entire post lights up on the right. So these may be appropriate where table 2C-5 that we went over last week indicates that chevrons are either recommended or optional. And then for all other roadways, delineators may be appropriate based on risk or crash history. And you can see MUTCD 3F.02 to 0.04 for color, size, height, and offset. So here's a page on the right from the MUTCD showing an example of delineator placement. And so if you ever wondered why you see delineators along the side of the road versus chevrons, it would be from this part of the MUTCD section. So part 3 would be where you would find this material. And then we have guardrail delineators. And so the MUTCD allows mounting of these delineators on guardrail, even though it is less than 4 feet above the edge of pavement and may be a greater distance from the roadway. So the MUTCD allows delineators to be placed as an option directly on the face or top of a barrier, even though height and offset may not match installation guidance. And as a note, the butterfly type delineators mounted inside the guardrail are not advised for installation under a post bolt head, as it may adversely affect the performance of the guardrail. And delineators can be attached to concrete and metal traffic barriers to provide linear reflectorization and alert drivers to approaching curves. So if you have guardrail, especially throughout a curve, and there's no delineators on it, you might want to attach some delineators to it, because it definitely helps provide the guidance for the motorists through the curve. As you can see here, especially at night, how it really stands out. There's different product types of these different delineators. Another thing to talk about is marking retroreflectivity. In the MUTCD in section 3A.02, it states that it's a standard that markings that must be visible at night shall be retroreflective unless ambient illumination assures that the markings are adequately visible. All markings on interstate highways shall be retroreflective. And then it goes on to say that on maintaining minimum pavement marking retroreflectivity is reserved for a future text base that the FHWA is having a rulemaking on. So there's actually the website for the safety.fhwa.dot.gov, and then you go to the roadway department, night visibility, pavement markings for more information. Says pavement markings are made retroreflective by adding glass beads or other optics. The retroreflectivity degrades quicker than the marking material. So there's definitely some maintenance involved with the marking retroreflectivity, but it does provide some good guidance, obviously, at nighttime. So it's an important feature to have with our pavement markings. So another type of pavement marking is where we have the words on the pavement. So as you can see in the picture above here, they actually wrote the word curve, and then down at the bottom you see it has the it has a speed. You put the advisory speed on the pavement as well. So the marking, the goal of this type of marking is to reduce the speeds in our horizontal curves. And so they have different methods, or it says do this, and it shows you the good examples. And then it says do not do this. So so it shows you what not to put and what they prefer. So the source of this information is a NCHRP Report 600, Human Factors Guidelines for Road Systems. So you can actually just Google that and download that report. It's a free report. And some other products we have for pavement markings, and we've actually used this quite a bit here in Ohio. These are speed reduction markings. And so these speed reduction markings give drivers the illusion that they're traveling faster than they really are. And so it involves these tick marks along the inside and outside edge of the lane throughout the curve, and they're spaced differently. And so as you can see in the bottom picture here, it shows how the spacing of these tick marks, what they look like, how they get closer together as they approach the beginning of curvature. So the theory is if the motorist feels like they're going too fast, they'll slow down. So here are some good resources that the FHWA has on their website. So they got the enhanced delineation for horizontal curves website that you can go to, and also the low-cost treatments for horizontal curve safety came out in 2016. So I recommend both of these websites and the information that they have in them. And you can download this booklet you can download and look at for free. Okay, so let's see if we achieved our learning outcomes for signing and pavement markings here. It says, so let's see if you can answer these. You can write these in the chat box. It says, identify signing and marking countermeasures to reduce roadway departures. Which countermeasures did we discuss to reduce roadway departures that involved signing and marking? You can help me out here, Paula.
Sorry, I'm here.
Okay.
There are.
I asked it.
It's only one response. Reflective signing and stripping.
Okay. Give him a few more seconds here.
Okay.
There's the chat box.
There we go. There you go, Ray. They're coming in now.
Okay.
RPMs.
What do we got so far?
They should be popping up for you. Wide pavement markings, chevrons, delineators, enhanced signing, flashing signs, reflective striping, RPMs.
Okay.
Retroreflectivity.
All right. Very good. Let me bring this back up here. Okay, so very good answers. We definitely went over advanced curve signing and advisory speed plaques, chevrons, edge lines, center lines, delineation, and those were good answers. I'm glad there's people out there listening to me ramble on. So next we have, let's see, did I go too far here? Describe the MUTCD requirements for signing and markings. Which of the following is true regarding the MUTCD requirements for signing and marking? So we have A, which says the MUTCD requires edge lines on all roads. B, in some cases, it may be appropriate to use signing and marking even if it isn't required by the MUTCD. C says markings that must be visible at night are required to be retroreflective. And D, at all curves where an advance warning sign is required, chevrons are also required. So in the chat box, tell me which of those is true or which of those are correct.
Ray, these are going to show up in your questions box.
Okay. There may be more than one. Okay, I see him. Starting to see him. I see Denise and Charlie and Tanvir. There could be more than one correct answer. There's your big hint. Oh, I see Matt Walter is paying attention. He might have to get extra credit. Kevin Dimmel, look at that. Good answer, Kevin. Good answer, Mike Hemmerich. All right, well, I see a lot of people have answered, so let's see. Let's go through these one at a time. So, let's look at answer A. It says the MUTCD requires edge lines on all roads. So let's think about that. It turns out the MUTCD And of course, the OMUTCD has criteria based on the width of the traveled way and the ADT, and for some narrow, meaning less than 20 foot, lower volume roads and less than 6,000 vehicles a day where edge lines are not required. So it's not A. So edge lines are not required on all roads. And B, let's see what it says. In some cases, it may be appropriate to use signing and marking even if it isn't required by the MUTCD. So as was shown with the Missouri case study, providing edge lines on lower volume roads can improve safety. So that is correct. So B is one of the answers. And then C, let's take a look at it. It says markings that must be visible at night are required to be retroreflective. Well, if we take a look at the MUTCD section 3A.02, it says that markings that must be visible at night shall be retroreflective unless ambient illumination assures that the markings are adequately visible. So that is correct. So B and C are correct. Let's see if D is. It says at all curves where an advanced warning sign is required, chevrons are also required. Well, if we take a look at the MUTCD table 2C-5 that we went over last week, it says that advanced warning is required when there's a 10 mile per hour difference between the posted and advisory speed. Chevrons are not required unless there's a 15 mile per hour difference. So that's not the case. So the answers were B and C. So I saw a lot of you did put B and C. So very good job. We did have a question there in the question box as well. It says, are these sequential flashing curve chevrons on only when a vehicle approaches or all the time? And as I was reading on that particular product, and it does say that it does detect an approaching vehicle. So they're not using, that particular product was not using its energy all the time. So it would detect an approaching vehicle and then turn on. Okay. Here's another question. Identify cost-effective enhancements that exceed the MUTCD requirements. All right, so which of these are enhancements that can be made to improve safety? We can double up the advanced warning signs. We can provide fluorescent yellow prismatic sheeting. We can use red background on warning signs, wider edge lines, placing chevrons on both sides of the road, or using delineators in curves where chevrons are not required. So which ones of those are cost effective and they exceed the MUTCD requirements and they improve safety? Pretty important. We getting some answers in here? Yes, I see. Okay. Okay, come on, people. I only see 4 answers. Okay, here we go. Kevin says A, B, D, and F. Okay. Kendra was A, B, D, and F. Vina with A, B, D, and F. Okay. Let's get a few more in here. Tan beer says B, D, and F. This might generate controversy. But what's a class without some controversy, for gosh sakes? Where's Dave Holstein in all this? I saw his name on here. Vina with some clarification. My answers were for cost-effective enhancements to improve safety. All right, good. Okay, well, that's enough. Let's go over the answers here. So we needed to make sure which one of these were cost-effective, and they exceed the MUTCD requirements, and they improve safety, of course. All right, so let's see here. A does do all those things, doubling up the advanced warning signs. We had a good picture of the doubling up of the advanced warning signs before that one curve where they had a visual trap. Remember, where the telephone poles kept going straight, but the road curved as a visual trap. So we recommend doubling up the advanced warning signs, especially with our township sign grant that we have to help townships buy all their roadway signs. How about B? B is the correct answer for this as well. Fluorescent yellow prismatic sheeting. Yellow is the color for warning. How about C? It says no, use red background on warning sign. So warning sign is yellow. And it turns out that the color of the signs cannot vary from the MUTCD requirement. So if it's a warning sign, it must be yellow. Wider edge line. So we went over those, and so these are definitely meet the requirements for this question, and it shows how they went from the standard 4-inch edge line to a 6-inch, and how it reduced crashes by 22%. Placing chevrons on both sides of the road. So we do not do that. It says chevrons are only placed on the outside of the curve. So we don't do that. And then the last one, F, using delineators and curves where chevrons are not required. So we went over that and showed there's actually a section in the MUTCD that discusses delineators in places where chevrons are not required, but where they're recommended, you could use delineators. So the answer is A, B, D, and F. All right. All right, good job, everybody. That was our module number 2 on signs and pavement markings, and how we can how we should strive to go above and beyond basically what the MUTCD says, and the effect of these safety enhancements at a low cost, how they have an effect to improve safety, meaning reducing crashes. Okay, so let's have a little knowledge post-test. So the question is, what treatments to reduce roadway departures are present in this picture? and what factors are present that make this treatment critical at this location. You get extra credit if you tell me what is going on in this picture. What we call, it's this term we use when it looks like something's happening, but it's not. All right, Charlie Lewis. And what's that called, Sarah Rowland? What is that situation called? Okay, we're getting a lot of participation here. That's very good. All right, so let's go over the answers here. So what treatments to reduce roadway departures are present? Let's see, we've got some signing and delineation treatments. We got edge lines and center lines. And then we have the advanced warning sign and advisory speed plaque. Something that's not present that may, let's see, chevrons are not present. Maybe they're required, maybe they're not. So what makes the advanced warning sign particularly critical at this location? It's because the utility poles and secondary road may give the appearance that the road is going straight. That's the visual trap. A slight crest vertical curve restricts the sight distance, so you don't see the curve. So you don't even see the road going to the right. So it's pretty critical there to have that sign. That picture was taken in Montana, by the way, not in Pike County that you may have suspected. Okay, so any questions so far as we wrap up Module 2? Okay.
Ray, I don't see any questions in the questions box.
All right. Well, then I vote that we go on into Module 3. How's that? All right, so in session 3, we're going to continue talking about our number one strategy of reducing roadway departures, and that is to do what we can to keep vehicles on the road. And we're going to talk about pavement friction and what it can do for us to keep vehicles on the road. So our learning outcome in this session 3 on pavement friction would be to identify locations with increased friction demand and name the unique components of the high friction surface treatment, which is HFST countermeasure, and to recognize the crash reduction potential for high friction surface treatments. And since we learned about these, I don't know, 5, 6 years ago or 7 years ago that I first heard about them, we've been using them quite often. And they really do have an impact on reducing crashes in locations that need more friction. So here is our knowledge pretest. Let me see. Let me get on the right page here. Okay, in this picture, we see a 2-lane curvilinear rural highway with an ADT of 4,000 vehicles a day. The curve radius is 280 feet. As you can see, the advisory speed is 30 miles per hour. And if we look at their crash data, they had approximately 30 wet crashes from 2006 to 2009 as a 4-year period. And the total and injury crash rates were 18.3 and 9.7 times the statewide average. So it's a very problematic curve. And so with our knowledge pre-test, we would, first of all, there is a website on the FHWA's, or actually it says rspcb.safety.fhwa.dot.gov in their roadway departure website with a lot of information about roadway friction treatments. So the thing about this curve is previous treatments installed that did not lead to any measurable crash reduction. It was they resurfaced it, 1-inch open grade asphalt concrete. They double stacked the chevrons. They doubled the number of speed warning signs. They installed a centerline rumble strip. The next step in their incremental approach was to consider realignment of the roadway, which would be a very costly project. And so they had, with their they looked at the number of wet crashes, which were high compared to other places. Given the average collision rate for 2-lane rural roadway and ADT, it should average only 2 crashes over a 4-year period. And they had 30 wet crashes. So what do you think could be done in a short period of time with less than $500,000? That is your knowledge pre-test question. What do you think could be done in a short period of time with less than $500,000? Okay, well, in a matter of saving time, I think you know what the answer would be, and that would be to install a high friction surface treatment, right? Okay. Okay, let's look at some skid-related crash factors. So it could be what causes skid-related crashes. Could be tire issues. Bald tires certainly don't help. Weather conditions, so rainy conditions, wet or icy conditions, aggregate friction characteristics. So it's the aggregate in the asphalt could get to be rounded and not provide the proper amount of friction. The bond capability of the pavement binder, so you're losing aggregate from the binder, and in the roadway itself might have a high friction demand. So those are skid-related crash factors. So here's another resource for you to find out more information from AASHTO. They have a guide for pavement friction. And so this is actually a very costly, kind of a costly book. But this one here that I just clicked on is free. It's a web-only document. It has all the same information. It says the NCHRP web-only document 108, Guide for Pavement Friction. So you can actually just Google that and view it, download it. So this web-only document 108 is the source material for the AASHTO guide for pavement friction. And on page 78 of the NCHRP guide, which is the chart I'm showing you on the right, it shows the following from the state of Maryland. So it says sites without any geometrical constraints are categorized as low frictional demand sites, while sites with geometrical constraints such as railroad crossings, traffic lights, pedestrian crossings, roundabouts, stop and yield controlled intersections, curves, hello, and freeway entrance exit ramps are categorized as high frictional demand sites. So here we have the chart showing the skid resistance as the x-axis and the accident risk, accidents per 10 to the 8th vehicles per kilometer, showing, you know, the more skid resistance you have, the less risk you have. There you go, the relationship between pavement friction and crash risk. Okay, so contributing factors for friction demand. You could have roadway geometry, like the curve you see in the picture, which we'll talk about. Locations where braking occurs, like intersections. Vehicle speeds, driver actions, and trucks. Trucks demand a lot of friction. If you're wondering why every time you see a nice exit ramp or something just got resurfaced, and then a couple weeks later you see ODOT came in there and roughed up the pavement, it was because we came out there to do some diamond grinding and provide more friction. It turns out that we at some point discovered that when an 18-wheeler turns over on its side at these locations, almost every time the 18-wheeler actually went into a skid and then flipped over on its side. So the theory is, let's prevent the skid, therefore preventing the rolling over on its side. Okay, so you see what I was going to say there. Okay, so let's go back to that picture here. So friction demand is compiled by a number of variables. So you got a road with tight curves or curves on a downhill grade like the one that you see here. It's a downhill grade plus there's an intersection. So that's like the double whammy, isn't it? Especially if people are traveling faster than they should be or not paying attention. And drivers who are not going the speed of the design or advisory speed on a curve can also incur excess friction demand on pavements due to the interaction between their tires and the pavement. In regards to trucks, their tire coefficient of friction is about 70% of passenger cars, but they also have about 10% higher friction demand due to size and weight of the vehicle. And so this is actually the picture of a crash location. A lot of crashes due to this curve and downhill grade, lack of friction that's in the state of Washington. Okay, so here we have the AASHTO horizontal curve design model. And for all you people that love physics and math, you must be thrilled to see we have a formula on the screen. Isn't that great? So the radius of the curve is equal to the design speed squared divided by 15 times the the super elevation and side friction factors added up. So this is from the AASHTO Green Book. I'm sure all my ODOT engineers had that one memorized. But the key message here is to introduce the AASHTO horizontal curve design model and the different factors involved. And so when a vehicle moves in a circular path, like in a curve, it undergoes centripetal acceleration toward the center of curvature, although drivers feel it as a force pushing them outward. And from accumulated research and experience, limiting the values for super elevation and friction have been established for curve design. So there are some assumptions in this AASHTO design model, and it's that the passenger car tracks the curve as a point mass, and the passenger car operates at a design speed through the curve. So we're assuming that the car is traveling at the design speed. all the way through the curve. And the curve design should avoid loss control due to skidding, i.e. during cornering. The model is intended to produce operations that avoid loss of control due to skidding, which would occur if the side friction demand exceeded the friction provided by the tire and pavement surface. And appropriate values for curve radius for a given design speed are influenced by the amount of super elevation provided. You know, the problem with a lot of our rural roads, like county roads, township roads, and some of our state routes in rural areas, is that there's no super elevation. So if you look at this formula, you know, it's dependent on both super elevation and factor. Well, guess what? A lot of our roads, our buddy super elevation just left town, right? So all we have basically to hold people on the road is the friction. And so that should explain to you in itself why friction is so important. So if we rearrange the formula there and put super elevation and friction on the left, then we could demonstrate the importance of friction, especially since there's no super elevation, and just to show the importance of friction. All right, so that's our little background on that. And then we have our curve design model versus reality. So this curve model that I just showed you, the basis of that is driver comfort. And it assumes that the vehicles do not exceed the design speed of the curve and that it traverses the curve following a constant radius. But in reality, the likelihood of skidding increases when these assumptions are violated. And several studies have shown that under real world conditions, both of these assumptions are violated. Okay, so in the MUTCD, if you studied that a little bit, you'd see that the advisory speed may be the 85th percentile speed of free-flowing traffic. And then when we did our ball bank study that we talked about last week, the speed corresponding to a 16-degree ball bank indicator reading, or speed otherwise determined by an engineering study. So these are the speeds that we deal with when we study a curve. And so a lot of, like it says, a lot of times these assumptions are violated as cars drive through these curves. They're either driving too fast or they're not staying in their lane, which they're supposed to do. We also talked about last week how a big percentage of head-on crashes happen in curves. That proves that people are not staying in their lane. They're not traversing the curve following a constant radius, in other words. So if you want more information on this NCHRP report 500, volume 7, deals with a guide for reducing collisions on horizontal curves. So they even talk about friction in that booklet as well. Okay, so if we delve deeper into this relationship between friction demand, speed, and friction availability, then we can further see why in a lot of cases friction needs to be enhanced. So here we have the pavement tire friction capability graph, and then we also have the friction demand of the vehicle there on this chart. And so let me get to this. So basically, you know, it's not a good thing when your car is driving through the curve and the friction demand exceeds the pavement tire friction capability. That's at the point where the skid begins. So we need to do what we can to prevent that from happening. So there's the speed of the impending skid is at the intersection of these two lines. So here's some common methods to restore or add friction. We have the thin hot mix asphalt overlay, or the open graded friction course, or ultra thin bonded wearing course, or a slurry seal or micro surfacing, or a chip seal and seal coat, and then the diamond grinding that you see on our interstates and interstate lookalikes, or grooving, and then high friction surfacing. These are all quite common in these days, and any of these may be an appropriate solution depending on the definition of the problem. But we want to focus on our high friction surface treatment and how it's used as a critical spot improvement. So first of all, what makes up a high friction surface treatment? So there's two parts to this treatment. You got the polymer resin binder, and then the aggregate itself. So there's three types of the binder. Three types of binder. The design of the binder is evolving with many new products becoming available. The most common binder used is the epoxy resin, but many of the others work well also. But you may have some drawbacks like cost or placement restrictions. The binder locks the aggregate in place and provides the needed tensile strength to transmit the vehicle load to the pavement below. And then the aggregate that we want to talk about today is called calcined bauxite, and that's because it provides the highest resistance to polishing and friction durability. So bauxite is available from Arkansas and is now being calcined in Alabama. So there's a local U.S. source for the aggregate rather than getting the rock from India or China. So when they first came out with bauxite, it was very costly. But in the last 3 or 4 years, the cost has been coming down because we can get it locally, or in the U.S. at least now. So why do we use the high friction surface treatment? Well, with the bauxite, it resists polishing when compared to other aggregates. And the high quality binders improve aggregate retention. So it's the combination of the bauxite resisting the polishing to become rounded, and then combined with the high quality binder so that the aggregate actually stays on the roadway longer. So placement of this treatment in the curves, it receives the shear and tensile forces not found in tangents, which can accelerate polishing when excessive friction demand occurs. Quality polymer binders placed properly are required to retain the aggregate. Aggregate loss can result in lower friction values over time. Aggregate needs to be embedded 50% into the polymer binder for installation longevity. So as you can see in the pictures, actual project where they're, they've placed the binder first, and then they have different methods of placing the aggregate on top of the binder. Here's an example of this video shows how the reductions of 25 to 30% affect the stopping distance. So it's, I don't know if you can hear this or not, but at least you can see it. Okay, so you can see that the car actually did come to a stop sooner than the non-treated lane of travel. So this was done in 2013 using calcined bauxite, and on a 3-run average, the friction value on the concrete pavement was 52, and that was like the before treatment. And then on the high friction surface treatment, the friction value was 85, and the stopping difference was between 25 to 30%, regardless of the speed. So you could probably talk to some people that were involved in crashes that wish they could have stopped 25 to 30% shorter. Okay, so where can friction benefit safety? At high crash locations that involve wet weather related crashes, and high friction demand locations like curves or intersections, or like that one picture, it had a curve and an intersection, it was downhill. Or poor pavements, which are they have marginal friction caused by the weather, or places that have friction values not compatible with approach speeds and geometrics. Okay, so at intersections and downgrade locations, you might have a rear end collision problem. And it's a particular issue for intersections and curves, since both stopping and side friction can easily exceed conventional pavement friction, which may lead to one component suffering a deficiency in friction unless more is supplied. And since vehicles can actually stop in a shorter distance, the high friction surface treatment can help improve stopping distance to reduce collision at intersections. Also, the downgrades in conjunction with curves increase friction demand for all vehicles, but particularly for trucks. And this is an especially good countermeasure for ramps, since they tend to have this geometry. So horizontal curves, when we talk about road geometry, that's definitely a place where we would get a lot of safety benefit from this high friction surface treatment. So they've studied this treatment, and they've come up with some recommended distances ahead of the point of curvature to begin the high friction surface treatment. So again, it's not your entire roadway. We apply the high friction surface treatment. When you do it for a curve, you do a certain distance ahead of the point of curvature. So you look at your approach speed. A lot of 2-lane rural state routes and county roads and township roads have 55 miles per hour. So in that case, you look at the advisory speed for the curve. So like if you have a 35 mile per hour curve on a 55 mile per hour roadway, it says you would begin this treatment 194 feet ahead of the point of curvature. Or if you have a sharper curve, 30 miles per hour, then that's 230 feet before the point of curvature. And this all came about from the research study was done by Texas A&M University. And so there at the bottom, they have a link so that you can read up on their research results for that. Okay, so I'm going to see if you can hear this or not, but at least you can see, here's a video where they studied a problematic intersection involving it's a curve and an intersection where they had a lot of crashes, and you'll see what they did here. And they've interviewed, the chief of police and the PennDOT engineer, safety engineer that was in charge of this. So I'll run this, see if you can hear it.
We are very excited about using high friction surface treatment. We chose this particular curve because it's a unique crash history.
There was a majority of crashes were occurring in wet conditions. In fact, over a 3-year period, there were 26 crashes.
Since I've been here as the chief of police, this intersection has been very problematic for us. We frequently have to park a marked unit there with the emergency lights on to try to slow people down. It was not the speed that the vehicles were traveling. It was the road surface being wet that contributed to the accidents. We contacted the Pennsylvania Department of Transportation, spoke with Steve Pohowski, an engineer, and we worked together to come up with some kind of a solution.
I've been doing low-cost safety improvements for over 10 years, and I've never seen such an immediate positive response to a safety treatment. In our use of high-friction surface treatment on curbs, we've seen a day and night difference in accident reduction and even elimination. Quite simply, it stops crashes from occurring.
Absolutely consider this road surface material. This eliminated our accidents. Since the material's been applied, we've had, I believe, only one reportable accident at that location. So it basically eliminated all accidents there.
Okay, so I like this. Let me hang on here. I'm pausing this video here just so you can see the. We talked about super elevation. Most of the roads, 2-lane rural roads, have 0 super elevation. This has negative super elevation, so that really contributed as well. As the cars come whipping around this curve, it's actually, they're going downhill through the curve at this critical point here. So you can see how the impact of low friction plus negative super elevation could contribute in the sharpness of the curve. So there's definitely high friction demand, but low friction availability.
We are very excited about using high friction.
So here's some more information on that particular curve. You can look at it from an aerial view, the different traffic volumes, and the number of crashes. Between October 2009 and October 2012, they had 26 crashes. And then afterwards, from November 2012 to November 2015, they only had 1 crash. And the friction value or skid number before was 22, and the friction value afterwards was 75. So 22 is never a good friction value. Usually a newly resurfaced asphalt pavement has about 42. And so as you can see, the high friction value is 75. Whoops. Okay, so the Florida DOT, they've been using the high friction surface treatments for some time now, and they actually have a publication that you can view online, and the link is at the bottom of this slide. So they've created this table here with the information that they've experienced, and so with involving crash rates before and after the high friction surface treatment on tight curves. And so the darker blue is before, and the light blue is after. And so the average crashes per million vehicle miles traveled, they dropped. Total crashes, 40% drop, and wet weather crashes, knocking them down to from 0.6 crashes per million vehicle miles to 0.1. So these are drastic improvements, and so that's why we want everybody to consider using this high friction surface treatment in areas for high friction demand, and especially if you have the crash experience. Your data shows that you have problems, wet problem crashes, or even dry crashes in the curves and in other places that where you can get this sort of benefit. Okay, so remember our pre-test. So let's where we asked you what sort of treatment could be done for less than $500,000 on that one picture. So in this area, in this location, the high friction surface treatment was more seriously explored as an interim option for the multi-million-dollar reconstruction project, which was $14 million with 2 to 5 years of planning and 6+ months of construction, which would have included a very lengthy detour over the next several months, where that section would have to be closed. The high friction surface treatment was installed, planned and designed less than 6 months and installed in less than 2 weeks with single lane two-way traffic control in 2012. And there have been 0 reported crashes through 2015 on that section of the highway. So installed in 2012 and after 2015 it had 0 crashes. So over 30 wet crashes to 0. So now you can see why the Federal Highway Administration is really imploring everyone to consider the use of high friction surface treatments, because it just almost totally eliminates these types of crashes. Okay, now what? Okay, so another resource you have is this booklet from FHWA titled Evaluation of Pavement Safety Performance. And it talks about the safety performance for curves, and it looks at the crash modification factors from the Highway Safety Manual and crash reduction factors for all crashes and wet pavement crashes. And you know, the crash reductions of, as you can see, some pretty big percentages here. 63% reduction in wet pavement crashes, 52%. So it says 8 state naive study versus a comparison site study. So I mean, again, drastic reductions in the number of crashes. And then, of course, we have another resource, which is the FHWA High Friction Surface Treatment website. So you can see the pictures on the right showing what the bauxite treatment looks like there at the bottom right, showing it has a quarter there to show you help you estimate the size of the aggregate in there and so forth. So that's a good website to check out. Okay, well, let's wrap up this. I'm running out of time here for today, but let's go over our learning outcomes review. It says identify locations with increased friction demand. How can high friction demand locations be identified? In the instance of time here, I can just go over this. So it's locations where you have polished pavements from high friction demand, like curves, wet weather crashes, lack of adequate super elevation, like we have on a lot of our 2-lane rural roads in our curves, intersections, and just places that have the low skid numbers or low friction value numbers. And then name the unique components of the high friction surface treatment countermeasure. What components are used in a high friction surface treatment? We have our calcined bauxite that is installed on the polymer resin binder. And then here we have recognize the crash reduction potential for high friction surface treatments. What are the crash reduction factors for high friction surface treatment installed on curves? So what does the Highway Safety Manual tell us about the potential for this treatment on curves? And it has the crash reduction factors of 24% for total crashes and a 52% reduction for wet crashes. So here's our knowledge post test. What issues do you see in this photo? So as we can see, it's a curve. It's got a crash history because someone put a cross on this tree. And so, so that indicates a fatal crash most likely happened there. So what could we do here? Would removal of the tree solve the problem? You know, if someone hit that tree, would removal of the tree solve the problem? Is it possible to remove the tree? As we take a look, so we see a fence. So the fence is likely the edge of the right-of-way. So maybe a barrier could be used at this location as there are multiple trees, right? Is the roadway super elevated? Well, if we take a look at that edge of pavement, it's almost like it's slanting towards the outside of the curve. So I don't see any super elevation there. And so how can the lack of a super elevation be mitigated? So the answer is the high friction surface treatment would be a very good way to reduce the risk of roadway departure, especially where the super elevation is lacking. And as far as tree removal, we're going to get into that in another module coming up very soon. So we'll get with that probably tomorrow about discussing the tree removal countermeasure. All right, so I know we're out of time, but what else do we have here? We have, looks like we have a question here. It says, what is the typical expected replacement interval for high friction surface treatment on a rural road? Replacement interval. I don't know if you mean the length of a job, but it'd be, you know, like that one chart shows us how far in advance of the point of curvature, and then maintain that through the curvature of the roadway. How long does it last? The lifespan. Oh, I see. So, you know, we can, when you look this up on the on those booklets and stuff, it's surprising how long the bauxite lasts. The bauxite lasts by far the longest, and that's why it's recommended. I mean, you'll see like 8 years and things like that in a lot of cases. But you know, if you use the regular asphalt like micro surfacing, that only lasts for a couple years probably for it to have a safety enhancement. So the bauxite, you know, if you listen to Dick Albin talk about it, I mean, it's really kind of a miracle, sort of an aggregate on how long it resists polishing and provides the safety benefit of the high friction value. So what are some high friction treatments for concrete pavement? I believe you can use this treatment on the concrete pavement, but there was also some, you know, the diamond grinding, and there was a list provided there of different methods. Let me see that there. Was that the, let me see, what did I do with that? I had a list of, oh yeah, it was the hot, well, the ones that might be for, you know, they have some sort of open graded friction course, ultra thin bonded wearing course, of course, slurry seal microsurfacing, that's asphalt, but diamond grinding and grooving might be treatments for concrete. But the epoxy binder could be, I think, can adhere just as well to concrete as it does to asphalt. So, and Brian Cunningham has stated here. It says, yes, this high friction works great on concrete, pavement, and bridge decks. So, very good. Thank you, Brian. Okay, well, I think that's it for today. So we successfully got through part 3 on friction. And so when we get back together tomorrow, we'll start on module 4. Let me see, what is module 4? Let's see what we got here. We got, we're going to be talking about our rumble strips and rumble stripes. So everybody, thank you for attending today. And, you will be getting certificates for each one of these sessions. We're just behind right now, but we will catch up. And so have a great day, and we'll see you tomorrow morning. All right. Goodbye.